In this video we will start with properties of union. There are 5 properties of union. So we will start with our first property. This is the first property. So first property is called commutative law. Okay, we will understand commutative law. So if I take an example of any set, let's say A is a set that has element 1 2 3, B is a set that has element 4 5 6. Okay, these are the element B has and A has. Now if I find A union B, so A union B is a set that has all the elements of A and B. Okay, so this is the set A union B. Similarly, I can find B union A. So B union A is the set that has all the elements of B and A. So these are the element. So this is a set A union B and this is set B union A. So you can see both the set are equal because A union B is equals to B union C. You can say here I have proved using an example. This is set A, this is set B, this is A union B and this is B union A. So if you see A union B has element 1, 2, 3, 4, 5, 6. B union A also has element 1, 2, 3, 4, 5, 6. So by this condition we can say that A union B is equals to B union A. I can prove in this way. Okay, next we will see next property, which is this property. So इसको proof करने का हम Venn diagram use कर लेंगे, बहुत simple होगा. So first I will prove this A union B union C. Okay, we will draw Venn diagram for only this part. For this part only we will draw Venn diagram. Okay, so इसलिए खाली हम इतना लिखा है. तो इसके लिए Venn diagram बनाएंगे तो so there are 3 set. So there are 3 set. Okay, so 1 2 and 3 set. By default assume all the 3 sets are intersecting. Okay, now we will shade the region first. So how to proceed for this? Okay, first start with, so this is the given set and we have to draw a Venn diagram for this. So first start with the bracket. Okay, find the shaded region for A union B, then find the shaded region for A union B union C. Okay, now A union, first is A union B. A union B is the region which has A union B is the set that has all the element of A and B. Okay, and we have seen how to shade A and B. अगर दो सेट होता है, सपोज ये A है और ये B है, तो A यूनियन B क्या रहेगा? A यूनियन B का रीजन कौन सा रहेगा? पूरा रहेगा A यूनियन B का रीजन. ओके, ये पूरा जो रीजन रहेगा ये रहेगा A यूनियन B का रीजन. सिमिलरली वी विल ड्रॉ. सो हम लोग पहले नेमिंग कर लेते हैं. दिस इज A, this is B, this is C, this is universal set. So A union B means region of A plus region of B. We have to shade both the sets region. Okay, so A union B will be this complete region. Okay, this complete region is the A union B. Then we will draw the region for C. So simply I will copy this. So now we will shade the region for C, only C. So this is the region for C. This is the region for C. Okay, now this is the region for A union B. This is the region for C and A union B and C, इसके बीच में क्या है? यूनियन है. ओके, मतलब दोनों को कंबाइन करना है. ओके, अगर दोनों को कंबाइन करें तो हम लोग को जो रिजल्टेंट जो शेडेड रीजन बनेगा वो पूरा बन जाएगा क्योंकि हम लोग को दोनों को कंबाइन करना है. ठीक है, ओके. So let me clarify it again what I have done here. So in the first diagram we have shaded the region for A union B. Okay, in the second diagram we have shaded the region for C. Okay, then in between this set and this set there is a union. That means we have to shade the region for this as well as this. So we have basically combined A union B and C, so therefore this region is shaded now. Okay, so basically we have to combine this and this, तब जाके ये मिलेगा मेरे को. Okay, so I can write here, this is the shaded region is A union B, the shaded region is set C, and this is the shaded region for A union B union C. Now we will, now this is only for this one. Okay, this is only for this one. So इसका जो region है वो है ये पूरा region. Okay, now we will same thing we will prove for this right hand side. So for right hand side, it is given that, or it is given A union B, B union C. So A union B union C. Okay, this is in the right hand side. So in the right hand side it is given A union B union C. So first we will shade the region for B union C, or you can shade the region for A also. Okay, so anyway you can approach, first you can shade for A, then in the second diagram you can shade for B union C, or in the first you can shade B union C, then in second diagram you can shade A, whichever you want you can go for. So I'm going like in the sequence, like we have to shade A first. Okay, so if you shade A first, so this is the region of A. Let me take another color. This is the region of A. This is the region of A. Then we will shade the region for B union C. B union C. Okay, we'll shade the region for B union C. This is shade the region for B. This is the region for B, and this is the region for C. Okay, B union C means we have to shade the region for B as well as C. So this is the region for B union C. Then what is there in between? This is set A. This is the diagram for A. This is B union C. This is the diagram for B union C. Then in between it is union, means we have to combine this set and this set. Okay, so after combining we will get, so on combining we will get again the same region as left hand side. Okay, basically we will get this region. So in between A and B union C there is a union. So this is the region for A. Okay, A का region ये है, B union C का region ये है. Okay, now what we will do, we will combine this and this. Okay, if we combine both then we will get this region. Okay, by combining we will get union. So this is the region for A union B union C, and this is the region for B union C, and this is the region for A. Okay, so you can see at the last diagram, this is the shaded region for A union B union C. This is the shaded region for A union B union C. So both these are equal. So both these are equal, because in this diagram this region is shaded, in this diagram this region is shaded, and in both the diagram the region shaded are equal region. Okay, therefore both are equal. That means this is equals to this is. So this is how you can prove using Venn diagram. Okay, this is how you can prove using Venn diagram. So let me write here, this is LHS, and this is RHS. So you have to use this method to prove some certain problem, like this problems. Okay, we will use this again in our next property. So what is the next property? Means we will use this method in the properties of intersection. But for now, what is the next property? Next property is A union phi. So this was the proof for first property. This was the proof for second property. Okay, next we'll move to third property, which is A union phi. So union means So we can prove this orally when we don't need anything, or you can simply in continuation to this proof we can prove this one also. So here I have taken set A. So we know that phi has no element because phi is a null set. Phi has no element. So A union phi, what will be A union phi? What will be A union phi? So union means element of A as well as element of phi. But element of phi, there is no element in phi because phi is a null set. So in the union there will be element of A itself, not more than that. Okay, only element of A, because in union what we do, we write all the element of first set and all the element of second set, but it has no element, only A has element. That means A's element will be there in this set, so therefore this set will be equals to A every time. Okay, now in the third it is given A union A. So A, this both set are equal, this both set are equal. That means here will be element of A only. So because union is there, that means we have to write element of this as well as this, right or not? Union is there, element of A plus element of A, but both set are equal, so we won't be repeating the elements. So all the element in the set will be element of A, therefore A. Next it is, this is universal set, this is union, this is A. This is universal set, union A. Okay, so universal set universal set union A. Okay, so we can understand, we can understand by example, but I want to tell you a simple method. So if there is a condition, if there is a condition A is a subset of B, if there is a condition A is a subset of B, that means all the element of A already belongs to B because A is a subset of B. If A is a subset of B, then A union B will always be the B. Okay, this is the method, this is the way to write. Okay, it is always true, it is always true, it is always true. Now if A is a subset of B, A union B will be always B because A has already every element in the B. Okay, so because A has already every element in the B, the union will be itself B. This is a property of subset and union. Okay, so basically if A is a subset of B, then A union B will be the superset because B is the superset, A is the subset. So that we can use that here we can use that here because I told you in the video which has which has the in which I was explaining about universal set. Universal set is the biggest superset. That means every other set will be the subset of universal set. So here A is the subset of universal set. That means A is the subset of universal set, and that means universal set union A will be U itself, will be U, universal set. Okay, universal set subset A, sorry, universal set union A will be universal set. So by using this property we have proved that universal set union A will be universal set. So this was proof of the first property, this was proof of the first property. Okay, then then this was proof of the second property. Then we have discussed third property here by considering null set. Then A union null set will be A itself. Here I have proved the third property. Then fourth property we have discussed that both set has same element, so union will be itself A only. And we have discussed here that if one set is a subset of another set, then union of both set will be the superset. Whichever the superset is, that will be the answer. Okay, so now for that reason we have said that universal set union A is always universal set. So this is for this class, this video. Okay.